Hi students, welcome to Mithran Educational Society's Mr. Physics YouTube class. Today we are going to be discuss the characteristics of gravitational force. Already we discussed the universal law of gravitation. Now we are going to be discuss about the characteristics and how the law is Newton proposed, right? That is called inverse logic. Now, the characteristics of gravitation. The main important points we are going to be discussed now. That means the gravitational force between the two bodies, right? I already said in the concept of the universal law. So the universal law is fully depending on the third law of Newton. Yeah, Newton's third law of motion. That is, every action has an equal and opposite reaction. That means the two body which should be consists of the action force as well as the reaction force. Without these forces, we can't able to find the gravitational force. It's a very important characteristic. Then, second one, it doesn't depend upon the medium between the two body. That means if the mass 1 and mass 2 which is present between them, right? So the between them only the force will be present. So there is any medium which is present between those two body, okay, it will not going to be affected. The gravitational force does not depend on the medium, right? So I hope you know whether you know the logic of the Coulomb's means. Because of that medium only we substitute the epsilon naught logic, permittivity, yeah, in a free space. In case medium in the sense permittivity of medium, epsilon we are going to be substitute. That concept is not here, does not depends upon the medium, right? Then the third one, it is a central force. That means we already discussed, we know that the system of particles center of mass, right, concept. The line join the center of mass of the two bodies, exactly the two bodies, the center line is called as the center force. So the characteristics of gravitational force is a central force, right? Then the fourth one, it's an important thing, it is a long range force. I think at the starting of the lesson we discussed the fundamental nature of the forces, right? At the time we discussed the weakest force is a gravitational force, the same thing, right? As well as the long range covered force among the four, which one is called as a gravitation, right? The long range force, right? It is a gravitation force up to infinite distance. The next one, the next logic is conservative nature of force. We know in the concept of the work power energy, the different types of the variable forces we discussed, that is called as conservative force and non-conservative force. The conservative force in that sense is called was, it is the work which is independent of the path, right? So it is a gravitational force is a conservative nature of the force. Fine. So these are the important, very important characteristics we should know. We are going to be study the gravitation, means we should know these properties, characteristics, we should know that, right? Then only we can going to be apply, right? Now we are going to be derive an important logic is inverse square law. How Newton he proposed F is minus G m1 m2 divided by r square, right? Fine. Shall we start? Right, our topic is inverse square law. Topic is inverse square law. Fine. Now, what initially is Newton going to be considered in the sense, he considered the sun is the particle which is around the sun. So this particle is rotating like this. That means it is a circular path. Yeah, very important thing. Newton initially is going to be considered, right, from the logic, right? So the planet which is revolving around the sun in a circular orbit, right? It's a pure concept of the heliocentric, I think. I hope you know, right? So it is a planet in the sense, definitely the force of attraction between the force planet between the sun, one force will be created here. So that force is called as FC, centripetal force, right? So centripetal force in the sense, I hope you know, based on the Newton's second law, F is equal to ma. A in the sense is called as centripetal acceleration. So what is centripetal acceleration? What is centripetal acceleration, right? Is minus v square by r. I think all of you know this, minus v square by r, centripetal acceleration formula. Otherwise you can't understand this one. Means a is equal to v by t. Instead of t, time is not depending here, because of the radius only it is depending. So instead of the t, again velocity by velocity displacement by time. So time is equal to displacement velocity v by r. You substitute that, you can find the answer of v square by r. Fine. Anyway, that are not a matter here. Now we are going to be find what is the velocity here. Velocity means it is what? Velocity means displacement by time. What is the displacement? Initially the point is here, again it is come back to the same point, so there is no displacement. So now we are going to be considered is a distance. Then so it should be covered. Yeah. So what is that? Right? Instead of that, just like a speed. Yeah. So that means 2 pi r divided by t. Am I right? 2 pi r divided by t. Now substitute the v value in acceleration. A is equal to what? Minus of 2 pi r the whole square divided by t square by r. Correct? So minus 4 pi square r square by t square divided by r. 1r is cancelled. So finally what is the acceleration in the sense? Minus 4 pi square r divided by t square. That's all. This is the acceleration. This is the acceleration. Centripetal acceleration, right? So it's an important thing. For a problematical purpose, we should be know, right, what is the centripetal acceleration, right, with respect to the semi-major axis of the planet, right? Then what is the time period they give? Means this is the acceleration way we are going to define. Or acceleration they may give, semi-major axis they will give, what is the time period of the planet they may ask. Okay, so remember this formula. Okay, or how to find the formula, right? That is enough. Fine. Anyway, what we are going to be find? We are going to be prove how Newton is proposed from the Kepler's logic. Yeah. So see, r is the distance, t is the time period, right? The semi-major axis divided by the time period is the logic of the Kepler. So according to Kepler's third law, the logic is t square is directly proportional to a cube. A in the sense it is here r cube. So we can say t square by r cube is constant, or r cube by t square is also constant. But this constant is 3 in the sense this constant is 0.3. Anyway, that is also constant only, right? Yeah, that will not going to be changed. Fine. So r cube by t square is constant. We have only r by t square. So how we can change the equation in the sense r cube we are going to be changed as r square into r divided by t square equal to k. So now we need only t by r square. So r by t square. So r square is going that side, means the equation like this will come. R by t square is equal to k by r square. Correct? Substitute this value in centripetal acceleration. Yeah. So what is AC? Minus 4 pi square, correct, r divided by t square. Yeah. So instead of the r by t square, now we are going to be substitute minus 4 pi square k divided by r square. Why sir we are going to do this? Yeah. So ultimately we are going to find the force. Force logic is what? According to Newton's second law, the force is equal to F is equal to m into A. So F is equal to m into A is what? Minus 4 pi square k divided by r square. Okay. So here the mathematical knowledge of the Newton becomes a very important role play going to be do. What does that means? The 4 pi square k, is that right? That numerical value should be equal to the gravitational constant and the mass. In case this is for example, this is sun, this is earth in the sense. Okay, so the gravitational constant, the mass of the sun, you can get the value of 4 pi square k, right? You substitute the value of 4 pi square k instead of gm, right? What does the answer will become? F is equal to minus gm divided by r square. Yeah. So this is inverse square law. By the logic of centripetal acceleration, starting from the centripetal acceleration, because it is moving, he considered the moving in a circular orbit. So finally he concludes that what does it mean? The ellipse circular in the sense is a small deviation, right? We are going to be it's an elliptical path in the sense you just consider the consistent elliptical path, you can get the circular path. It is not a very big changes there, right? So initially he considered the circular path based on the heliocentric theory. He going to be start, but after that without Kepler's logic he can't able to find this gmm divided by r square, right? So this is inverse square law, right? So thanks for watching this. Next class we are going to be discuss about centripetal gravitational constant is what, how we are going to be find that, right? Thank you.